This is a typical box AC that you will find in windows in the summertime. And it's actually a system that cycles refrigerant to carry heat from the room via the evaporator coil and out through the condenser to the outside air. So this part of it is facing the room and this part of it is facing outside. There are two other major components of this system, which is the compressor, this black box here, and the metering device. This black unit right here and the metering device, the function of those is to basically change the pressure. The compressor changes the pressure of vapor, and vapor is actually takes up more space than liquid, which is why this is so much bigger than the metering device, because the metering device changes pressure of liquid. These copper pipes are called various names. It's one copper pipe, but it's called various names, and it's at different sizes during the actual process because they do different things. So when it comes out of the evaporator, it's called the suction line. So I'm going to start here. You can actually start anywhere in the cycle because it is a cycle. It continuously repeats, and I'm going to start here. All right. So this suction line is quite thick, and it's already taking in air from it's already taking in heat from the room. At this stage, the refrigerant exists as a low pressure, low temperature vapor refrigerant, and it's sucking into this little black unit right here. I'm going to lift it up so you can see it. There's this little black unit right here, and it's like coming out of the suction line, and it's basically an air dryer, and it filters for impurities before it gets into the compressor. All right, so the compressor here, after it's filtered in the impurities, it goes right down at the bottom, so it goes into the bottom of the compressor, and at this point the refrigerant is superheated as it's just picked up heat from the room via the evaporator. So it goes to the bottom right here, and see this thick piece right here at the bottom of the compressor is at the bottom of the compressor, at where you have the low pressure vapor, and the job of the compressor is to fire up the piston, and it will basically change the pressure of the vapor that's inside, and it changes from low pressure, low temperature vapor, which is carrying the heat, to a high pressure, high temperature vapor. So after that, it will come out through the top right here, and so after it's sucked in, it then discharges out. So this is called a discharge line. So this line is actually a discharge line, and it's still superheated at this point. So it's the low temperature, low pressure air has now been condensed, and it's now, as it gets to the top, it's high pressure and high temperature. So it comes out here. This line is called a discharge line. These valves are not usually there. This is just there for the purposes of demonstration. But this line, now this same copper line, because it's part of the cycle, is called a discharge line. And it has high temperature, high gas, high pressure gas, vapor, basically, that's come out of the compressor, and it goes down through here, up here, into what's known as the condenser. So this is the condenser, and just imagine this is outside, and it's got all this high temperature, high superheated vapor that's just been compressed. So at this point, there's the refrigerant is now carrying heat. So it's carrying heat that's come in from the room, and it is now entering the condenser with high heat. So in the summertime, you know, it's really hot in your house, but the temperature outside should be cooler than what is in here. And cool air always attracts, well, hot heat always attracts cold. There's actually no such thing as cold. Did you know that? So there's just air with the heat removed. So now we're going to put the heat back into the atmosphere. So say a day like today is a 70-degree day and your room is 100 degrees. So this refrigerant air, this refrigerant now contains like 100 degrees and outside is 70 degrees. So that heat will be rejected from the condenser. So if you've ever stood outside of a outside of a window unit, you'll see that's on and you'll feel the heat coming out of it, and that's actually the heat that's coming out and blowing into the air. All right, so it keeps discharging the air as it enters the compressor. Okay, and there are coils in here. You can see like these things here, these are coils and it's carrying the heat. And as the heat is rejected into the air, it turns into like a saturated state in the middle. Some people call this the flashpoint. And at this point, the vapor changes state, it changes into a liquid, right? So when you think of the word condense, it's basically to turn something into a liquid. It takes something that's hotter, like a vapor is always hotter than a liquid. Like when you boil the kettle, that vapor that comes out is hotter than the actual liquid, but it's just dispersed more. So you know, it mixes with the air, so it feels a little bit cooler. But basically, as it goes in here, it changes into a liquid like halfway through. And so right in the middle, you have vapor and liquid existing at the same time, and that's called the flashpoint. And as I've already explained, the air that's outside takes the heat. So inside here, there's two fans. There's a fan, there's the fans right here that move. And these fans are actually pulling in the air from outside. So it's moving the air around. So it's actually pretty cool. It's basically helping it work once it's on. So as the heat is attracted to the core, the temperature decreases in the liquid refrigerant. So the temperature decrease is what's known as the subcore, right? So anytime the liquid has a decrease in temperature, that's known as the subcore. So after that, the refrigerant comes out of the condenser. See, it went in up here and it comes out down here, right? See? So it goes all the way around there. Goes coil, rejecting heat, and then it goes up and through here as a liquid, right? So it's changed state from a gas to a liquid. All right, so that's what the condenser does. And then it goes all the way through this metering device. And you can see that the metering device is just a coil that's covered by a sleeve. And it starts off thick and then it gets thinner, right? So anytime you see like a change in size, you can see that something else is happening to it. So it's a complete liquid at this point. When it comes out through here, it's a complete liquid. So it goes through this metering device as a liquid. So you have high temperature, high pressure liquid going into the metering device. And this metering device, you see how it's big? It becomes smaller. It changes it into low pressure, low temperature liquid. It still stays a liquid. So you can think of it as a valve, right? So it opens up, and whenever you have a temperature decrease, whenever you have a pressure decrease, you have a temperature decrease, usually. And that's what the metering device does, right? It changes the pressure, So now we have low temperature, low pressure, liquid, and it is going into the evaporator. The evaporator is where all the magic happens, because the evaporator is in your room and it's taking in the heat from the room. And so you have, out of this metering device, which is right here, you have this low liquid, this low temperature, low pressure liquid. And can you see how the coils here are much thicker, right? It's much thicker because it wants more surface area so that it can absorb as much heat as it can from the room, right? So basically, this metering device, when it comes out, the metering device, this little line here is called the liquid line. So as I was saying, it's just one system with different components, but the components are called different things. And the name of the components is a clue as to what state it's in at the moment. So it's a thin line here, and it has the valve there, and we can see that it's a liquid line. So the refrigerant comes out here and then goes into this evaporator where there are lots and lots of coils, and it's absorbing heat. There's actually 2 rows of piping here to catch more heat. And so when it's absorbed enough heat from the room, this also changes it. It changes it from a liquid into a low temperature vapor, right? So by the time it goes all the way through the coils, and it's absorbed the heat. It's absorbing heat, and then there is a flashpoint, right? So it's called the superheat. So before, in the condenser, it was a supercool because there was a temperature decrease, and now there's a temperature increase. So that's the opposite of what happens in the condenser. So now we have what's known as the superheat, right? So when it comes out of the superheat, it is super hot. And actually, when it comes out here, this is actually the hottest part of the cycle. Super heat, yeah? And it's still increasing heat, all right? So, so basically here, it comes out superheated as vapor. So it's changed state from liquid to vapor in the evaporator, and it's gotten hotter, so it's superheat. And then we start the whole cycle again. Its next destination is the compressor, and before it goes into the compressor, it goes into this air filter, and I just explained to you, basically I just explained the cycle of the AC system.